Hello. Today we're going to review the Cloud Native Computing Foundation demo that we have on Ravelo Cloud. Here we have 6 VMs. We have the master server, worker 1, and worker 2 for the Kubernetes infrastructure. Additionally, we have a Docker registry in Jenkins. First, we need to find out the public IP address of the master server. After that, we use that IP and point it out to the port 30001. In there, we will find out the WebSockets portal. It's a portal based on microservices. So we can show the customer how to scale microservices with Kubernetes. Also, on that same IP, but on the port 8001, we have the Kubernetes dashboard. But before, we should connect via Secure Shell to the master server, because in there is a file called token.txt. In there, we will find out the token to access the Kubernetes dashboard. Once logged in the Kubernetes dashboard, we will find out that is the master server, the worker node 1, and the worker node 2. After that, we should switch to the namespace of our web portal, which is called SuckShop. After we switch to the SuckShop namespace, we go to deployments. In there, you will find 13 microservices that together host the web portal. Later, we will use a third-party provider called loadimpact.com. In there, we're going to run a free test to stress the workload of our web portal. A few seconds later, the load test scripts will begin, and the portal will start to show load. This test will stress the front-end microservice. So we should show the customer that right now we are only running one pod. The rules for scalability are targeted to 20% of the CPU utilization with a minimum of one front-end microservice replica and maximum of 10 replicas. Since the test will endure 3 minutes, this is the time when you can show the developers in your audience what a YAML file is, because they might be curious about how the code looks like. After 3 minutes, the front-end microservices will scale to up 3 replicas. So the customer can see how a microservice will scale automatically with no human intervention. After a while, the deployments should scale down to just one instance of the front-end microservice. Then you can use the same IP of the master server pointed to the port 30,000, and then you will find Prometheus. In there is a metric called kubelet running container count. So you execute that, and after a while, you can show the customers the graph of how many containers are running on a determinate time. First, 10 containers. After the test, 16 containers. After a while, the front-end microservice will automatically scale down to just one pod and one instance. Okay, this is it. This is how we show customers how a Kubernetes deployment can automatically scale up and down a microservice. Thank you.